So we're going to do some problems. This is in your notes, and so you want to have this handy because I'll be referring to it. So we're going to start with sample problem number 1. If we go by this chart, we're going to start with sex-linked and recessive. So we're going to look and we're going to see if a female has the trait, then all of her sons will have the trait. So let's just look. So we're looking for a female who has the trait, and then do all of her sons have the trait? This one is a yes, and here's the female with the trait, and both sons have it. So basically, that's a yes. Keep going. Next one on this list. If a female has a trait, then her dad must also have the trait. So this female has the trait, and if you look up, so does her dad. Now, what about this female? Well, we don't know her dad, but we do have one, so that's also a yes. So far, we have not proven otherwise. Next one, if both parents do not have the trait, so they look like this, then they can have a boy who has it and a girl that doesn't have it. So a girl cannot have it if both parents do not have it. All right, so we don't have that example up here, right? There is no both parents not having the trait. So this is like a NA. It's not a yes or a no because we don't have that example. So then we move on to the next one. If both parents have the trait, so this and this, then all of their children will have the trait. So both parents have the trait. All of their children, no. So we found a no. This is a no. If this is a no, we move on. So it's not sex-linked and recessive. So now we try autosomal and recessive. So if we try autosomal and recessive, it says if both parents do not have the trait, again like this, they can have children with the trait. So we have both parents who have the trait, and they do have a mix. So that's okay. So that's kind of a yes, it works. If both parents have the trait, then all of their children have the trait. Both parents have the trait, but not all children have the trait. So it's not autosomal recessive. So that's a no. So we already clicked off no and no. Last one. Autosomal dominant. We're pretty much going to go ahead and start penciling it in because we think it's going to be correct, right? So now let's look at the labels. Everyone that is circled dark in, they have the dominant characteristic. So that's what I usually just kind of hone in like one at a time or my brain gets confused. So this one that is filled in has a capital A. So I find all of them that are filled in has a capital A. Now, if I look back on this, if they do not have anything filled in, it's lowercase a. So that would be little a, so this is how I fill out all of them. This is how I start. Now you have to understand genetics, which I hope by now you know that this parent is either going to give this little a or this little a. This parent is going to give this a or something else, whatever they have, to their child. So kind of a lot of times I work backwards. So if this child is little a, and they got one of them from this parent, they did not get both. They cannot do that. They only got one. So what would this parent have to have? This parent would have to have a little a. That's the only way you get this child. How about here? Well, this child has a capital A, got that one. What did they get from this parent? Oh, they would have had to get a lowercase a. Now I'm going to skip the husband here and scoot over to the other child. Already done. All right, so we're kind of done there because usually I look down at the next generation. So now I have this set up where I know this is a capital, this is a capital. I know they have the lowercase because of the parent. Now what about down here? So these two children have lowercase a. They got one from this parent. So what do they get from this parent? A lowercase a. Now, this parent could have given this letter. This parent could have given this letter. So I have no idea what the other letter of this child is. Because it could be big A, or it could be big A, little a. So I don't know. So when we don't know, we just put a little dash. We have no proof one way or the other. How about here? Well, this parent is going to donate a lowercase a. So both of them are going to have that. But what about this parent? Wouldn't really know, right? We don't know their parents. And this A definitely could go to either one. They could have two capital A's, or they could have a lowercase a. So this parent, we don't know either. And so that is the proper answer. This is for sample problem 1. In sample problem 1, we decided that this was autosomal and dominant. So you'll be filling this out, and then I will be asking you problems on the worksheet. On your practice will be, so this is not labeled, but I can easily label these. And you can do it too. It's not rocket science, right? But so then I could say, what is the genotype of individual 2, 3? And then you would tell me capital A, lowercase a. What is the genotype of individual 2, 5? And you would tell me capital A dash. Don't know. How many individuals on this problem have the characteristic? That's asking you to count the shaded boxes. 1, 2, 3, 4, 5, 6, 7. So how many? Count. How many are homozygous recessive? Count. 1, 2, 3, 4, 5. So I could be asking you the genotype of an individual. I could ask you how many there are. Those types of questions will be what I ask you on the practice. So the first step will be to identify what kind of trait, what kind it is, to then write out all the genotypes, then answer questions. So let's try sample problem number 2. Here we are, sample problem number 2. What is the inheritance pattern? Label all the genotypes. So again, we're going to start sex-linked and recessive. We have to prove it wrong before we get to move on. If a female has a trait, then all of her sons have the trait. Female has it, all her sons have it. Okay, we're good. A female has the trait, then her dad must also have the trait. Female has it, we don't know her dad. Female has it, the dad does have it. Oh, okay. That's a yes, right? If both parents do not have it, that's not a choice, so we'll skip that one. If both parents have it, well, that's not a choice. And only females can be carriers. That just means that you can have children and the female doesn't have it. But that one's kind of hard. I kind of skipped that one. So for me, we have not said no. It's still not 100% sure it's sex-linked, but we haven't said no on the little cheat sheet. So since we haven't said no, we're going to go ahead and try it. And that's what pencil is for, because we still could be wrong and we might still have to erase. But if we start filling this out, again, looking at our labeling, a girl who has it is X little a, X little a. So we'll go ahead, we can fill out that. So there's the girls. Again, I usually just try to focus one at a time. It helps me keep it apart. Okay. If a boy has it, X little a, Y. So this is really when it counts for the boys and the girls, right? Okay. If the girl does not have it, X capital A, X blank. Okay. So X capital A, X blank. And then the boy that doesn't have it, X capital A, Y. All right. Now we have a couple of blanks, right? We have this blank, and this blank. The question would be, can we solve this blank before we let it go? So can we figure out what this mom has based off the children? So the boys got a Y from their dad. That's the only way they're a boy. So it doesn't even matter what the dad has because boys get just Y. So the other one comes from mom. So far, yeah, the mom has a capital A, we know, because that's why she has boys who don't have it. We can't really tell what this other one is. And even here, if we're looking up, don't know. Well, actually, I take that back. See, this is when I'm thinking without recording. The girl got an X from the mom, and the other X has to come from the dad. Because the dad didn't give the girl the Y. That's why she's a girl. So we do know this one. Because her dad has the trait, we know she has to be a carrier. All right. Then down here, dad has it, so does the girl. So we know she's a carrier. So the only one we don't know is this mom, and it's because we don't know her dad. That's really why we can't tell for this mom up here. But we can tell for the daughters down below. So that is now complete. So we have one that we don't know. The rest of them we know. And again, I might be asking you how many boys have it, how many girls have it, what is the genotype of this individual. So those are the types of questions we'll be asking after you complete this part. So once again, this is the answer. And we did decide it is sex-linked and it worked. So had we filled this out and then we had noticed that these two parents can't have this, then we would have had to go back and figure out what was wrong. So we could still have found it to be no. But Sex-linked is the answer for sample problem number 2. Okay? Sample problem number 3. Back to this page, starting at the beginning again. And that's the part where it's like again, again, again. All right, if a female has the trait, then all of her sons will have the trait. Female has it, all of her sons have it. Okay. If the female has a trait, then her dad must have the trait. So do I have a female has the trait, her dad has the trait? No. So I already found a no. Since I found a no, it's not sex-linked. Next one, autosomal and recessive. If both parents do not have the trait, do we have that? Okay, here. Then they can have boys and girls that have the trait. They can have. So they don't have the trait, but they can have children that have it. Okay, that kind of works. Both parents have the trait. All of them have the trait. Nope, that's not a choice. And then females and males can be carriers, which hard to tell here if a female is a carrier. So I can't say no, which means I'm going to try this one. I might be wrong, but I'm going to go ahead and try it. And then again, I'm going to fill it out the way it says. So this is opposite of the dominant, right? So we're looking here. If they have the trait, they're going to be homozygous recessive. So I'm going to look at it, find all the ones that have the trait, and I'm writing homozygous recessive. Then, if they don't have the trait, then they're capital A something. So that's kind of step one once we've decided. Then we start looking at the parents and the children, and does it work? Does it match? And can we figure out what another parent would be? So again, here we have 2 A's. One came from this parent, so the other one had to come from that parent. Down here, 2 A's. The only way this child has 2 A's is if the parents are heterozygous, right? One came from one parent, one came from the other parent. So now this parent that's heterozygous could have given this one, or this one, this one, or this one. So we know they got a capital A, but it could be another capital A or a lowercase. So we cannot determine this one. We're going to have to leave that one the way it is. We don't know. And then we have this set. This parent is only giving a lowercase a, so the children have to have that. What about the mom? Don't know. Mom could be homozygous dominant and still would have this story. Or mom could be heterozygous and we would still have this. So we don't know that one and we don't know that one. So we have 2 don't know. So now we've completed it. It does match. It does make sense. I don't have a child that I can't explain genetically this way. So this inheritance pattern is autosomal and recessive. And again, then I'm going to ask you about the genotypes. Who has the trait? Who doesn't have the trait? What is their genotype? Which ones can you tell? Which ones do you not know about? Any sort of questions like that. Now, I know I made this into 3 different pages. So let's see if I can find my one that you can see completely filled out. And I will zoom out for you. And you can kind of get an idea of your completed notes page. So a little hard to get to. focus. But that is your completed notes page for problem.